So some time ago, a mathematician, physicist, found that this method to solve a quadratic equation that worked every time. And that method was called completing the square. And right here I've kind of highlighted the steps that we're going to solve to do that. But I got to tell you that they're a little hard to hear initially here. So what I'm going to do is I'm going to come back to these steps, but would you remember that they're here? Because, first of all, it says rewrite the equation with the constant on the right side of the equation is what that should say. If the coefficient in front of the x squared term is not a 1, you must divide both sides of the equation by that coefficient. Oh man, it gets crazy. Take half the coefficient of the x term, square that value, add it to both sides of the equation. Oh geez, we better not even go there yet. So completing the square involves, truly though, getting the constant on the right side of the equation. So I'm going to put the minus 16 over here on the right side. Please remember though, a bit ago when I solved this problem by factoring, I factored that into x plus 4 times x minus 4 because it was the difference of squares. And this binomial resulted in an answer for x of a negative 4. And this binomial resulted in an answer for x of a positive 4. So when I solve by completing the square, what happens is I get the variable term squared. And so I just take the square root of both sides because the square root of x squared is x. But what you have to remember is when you take the square root of 16, you don't just get a positive 4, you get a negative 4 as well because a negative times a negative is a positive 16. So a negative 4 times a negative 4 would be a positive 16. So you must remember your plus and minus signs. In this next problem, when I move that 16 over to the right side, it's going to be a negative 16. That's a little bit more unusual. I'll take the square root of both sides and I'll have x. Don't forget your plus and minus signs. But the square root of a negative 16, I've learned from a previous unit that that's an imaginary number, and it's equal to 4j. Don't forget, we call that 4j versus 4i. Many people in the theoretical math world use I for the imaginary unit. So there are two answers, 4j and a negative 4j. And see the original problem, x squared plus 16. If you took a 4j and put that in for x and squared it, 4j times 4j is 16j squared. But remember, j squared is a negative 1. So 16 times a negative 1 is a negative 16, and you add 16 to that, and you do indeed get 0. It would work the same with a negative 4j. I'm not going to go through that proof. So bottom line is, if I have something squared that involves the letter, even a binomial squared, I can take the square root of both sides, and the square root of something squared is just that something. So the square root of x minus 3 squared is x minus 3. The square root of 25 is plus or minus 5. And finally, to solve for x, I'm going to add 3 to both sides of this equation. So I have x by itself, and it's going to be a 3 plus a 5, which is an 8, and a 3 minus a 5, which is going to be a negative 2. So x will equal 8. And x will equal a minus 2, because remember, there's two answers. So let's go ahead and just check this one real quick. The original problem says take x minus 3 and square it to get 25. So if I put an 8 in here for x, is 8 minus 3, which is 5. And is 5 squared 25? Yeah, it is. And then if I put a negative 2 in there for x, I'm going to have a negative 2 minus 3. Which is a negative 5, but it's in parentheses, squared. And a negative 5 times a negative 5 is a positive 25, and it checks. So again, we continue on. Let's go ahead and take the square root of both sides, but I have an imaginary value here. So this would be x plus 5 equals plus or minus 4j. When I take this positive 5 over here, I subtract 5 from both sides. I always put it in front. So I would have a negative 5 plus or minus 4j. Yes, you could have written plus or minus 4j and then the minus 5, but I like to have the real part first and then the imaginary part, because the two answers here then are a negative 5 plus 4j, real and imaginary, and a negative 5 minus 4j. Those are the two answers. Okay, this last one, what I need to do is I need to take this trinomial over here and try to factor it into a binomial where it's a binomial squared, because that's ultimately, not all my problems are going to come like this, as x plus 5 squared and x minus 3 squared and x squared. So I have to complete the square. Sorry, I'm trying to be funny about this. So when I factor that trinomial, x times x is x squared. Well, what two numbers multiply to be 49? Probably 7 times 7. But they have to add to be a negative 14, so probably a negative 7 and a negative 7. So I'm going to bring this over here a little bit. So that left side turns out to be x minus 7, that quantity squared. And now I can take the square root of both sides of this problem. So the left is x minus 7 equals plus or minus the square root of 7. Please, don't do anything with that. Leave that as it is. The square root of 7 is a nasty number, but if you leave it like this, it's exact. See this minus 7? I'm going to put it over here, right here, as a positive 7, plus or minus the square root of 7. And so my two answers are 7 plus the square root of 7. Watch this. So my two answers are 7 plus the square root of 7. And 7 minus the square root of 7. Those are my two answers, 9.6 and 4.35. See this statement over here, number 5? It said take your x value and square it. So I'm just going to go ahead and take this x value and square it. And then I'm going to subtract 14 times that second answer. So it will use this, plus the 49. And I'm going to see if that does equal 7. Exactly. And the reason it equaled 7 exactly is because I used the answer. I used all these decimal places. If I just use 9.65, so if I go 9.65 and square it, minus 14 times 9.65, plus the 49, I won't quite get 7, but I'll get really close. But I only used 2 decimal places that time. So again, I can check my answers. I think I'm going to go ahead and introduce the idea of completing the square. So how do you do this? How do you take an expression and make it into a binomial squared? That's the idea in order to take the square root of both sides. Also, I must interject right now that this is a difficult procedure. But without this process, we would not have the method that most people use to solve quadratic equations, which is called the quadratic formula. Most people use the quadratic formula to solve, and it says that x can be found by taking the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, where the a's, b's, and c's are the coefficient of the x squared term is a, the coefficient of the x term is b, the constant is c, and the equation is set equal to 0. So we are headed here. But without this process, we would not be able to have the quadratic formula. So what I'm getting ready to do is a little bit unusual. I'm going to draw a square, and that square is going to represent an algebra tile called x squared, and it's because its dimensions are x by x. So when you multiply length times width or side times side, you get x squared. And then next, I'm going to create an algebra tile that's called a 1 by x, and it's going to look like this. So I'm going to add a 1 by x to the right side. These are getting a little bit bigger. And then down here, because I want to add 6 of these 1 by x's to my picture, because you see my algebra expression over there, it's plus 6x. So each of these tiles is x long, but they're 1 wide, so they're 1 by x, so that's an x, an x, and an x, and another x, and another x, and another x, and they total up 6 x's. And now what I want to do is I want to create what's called a constant, and that constant is going to be found by adding 1 by 1s. So I'm going to break up and complete the square. So this is what I mean by completing the square. I went here to here to here to here. I literally completed a square, but what I added in here is 1, 2, 3, 4, 5, 6, 7, 8, 9 little squares that are called the constants. So I had an x squared. I had these tiles called x's. There were 6 of them. And if I add 9 units to complete the square, then this trinomial would now factor into x plus 3 by x plus 3, which is x plus 3, that binomial squared. We're going to come back and do some more of this, and I'm going to use this picture still and talk about how you can find that more easily.